Good day, everyone. So, for this lesson, we'll be discussing the introduction to statistics, random variables, and probability distributions. So, first, what is statistics? It is a collection of methods for planning experiments, obtaining data, and then analyzing, interpreting, and drawing conclusions based on the data. While probability is a value or number between 0 and 1. Now, here are the basic concepts of probabilities. First, the random experiment. It is a procedure that can be repeated several times under the same condition. Sample space is a set of all the possible outcomes or result of a random experiment that is denoted by a Greek letter omega or S. Outcome is a result of the experiment, and event is a subset of the sample space denoted by any letter. Random variables and probability distributions. A random variable is said to be associated with a real number to each element in the sample space. And we use this term to describe the value that corresponds to the outcome from a given experiment. Now, a random variable is discrete if the set of the possible values is countable. Examples are numbers of male singers and the number of heads in tossing 3 coins. A random variable is continuous if the values are on continuous scale. These are variables obtained by measuring or that are contained in an interval. Examples of these are speed of cars and weight of grade 11 student in a certain year. Probability distribution is a function or a rule that assigns the value of a random variable to the probability associated with these values. To further understand this, let's try this example. What is the probability of getting a vowel in an English alphabet? We all know that an English alphabet contains 26 letters, while vowel letters contains 5. Therefore, the sample space is 26 because there are 26 letters in the English alphabet. The number of elements in the given event is 5 because there are 5 vowels, which are A, E, I, O, and U. Therefore, the probability of getting a vowel letter is 5 over 26. Another example, imagine we roll a dice. What are the possible outcomes if we roll it once? We all know that a die has 6 faces, which is 1, 2, 3, 4, 5, and 6, which are possible outcome once we do the experiment. To get the probability of this, the number of element in a given event, which is 1, because you only rolled the dice once, over the sample space, which is 6. Suppose 3 coins are tossed. Let y be the random variable representing the number of tails. Now, here's a table for the possible outcomes and the value of the random variable y, or the number of tails. In every toss, we can have one of the 8 possible outcomes in tossing a coin with a tail. As we are in for the tail, we could see in the table the number or the times that the tail is shown in every toss. So using what we've learned earlier, the probability of getting 0 tails is 1 over 8. The probability of getting 1 tail is 3 over 8 because as shown in the table, we have the HHT, HTH, and THH, just like our 2 tails. Same goes with 2 tails, which are HTT, THT, and TTH, which is why it is 3 over 8. And lastly, the probability of getting 3 tails is 1 over 8 because of the possible outcomes TTT. Now, mean is the expected value or the mean value for discrete random variable x can be computed by first multiplying each possible x value by the probability of observing that value and then adding the result quantities symbolically as the summation of x times px, or the probability x. Using the example earlier, construct a probability distribution for rolling a single die and find the expected value using the formula for mean, which is then 1 times the quantity of 1 over 6 plus 2 times the quantity of 1 over 6 plus 3 times the quantity of 1 over 6 plus 4 times the quantity of 1 over 6 plus 5 times the quantity of 1 over 6 plus 6 times the quantity of 1 over 6. And using your calculator, the total will be 3.5. Now, in getting the variance denoted by omega squared, it is equal to the summation of the quantity of x squared times p, or the probability x, minus mean squared. And for our standard deviation denoted by omega, it is simply the square root of our variance, or the omega squared. Again, using the example earlier and the formula for variance, substituting it, then it will be 1 squared times 1 over 6 plus 2 squared times 1 over 6 plus 3 squared times 1 over 6 plus 4 squared times 1 over 6 plus 5 squared times 1 over 6 plus 6 squared times 1 over 6 minus 3.5 squared, which will get the total of variance of 2.92. Now for our standard deviation, with the formula of the summation of the quantity of x squared times probability x minus mu squared, or mean squared, which will then be the square root of the summation of 1 squared times 1 over 6 plus 2 squared times 1 over 6 plus 3 squared times 1 over 6 plus 4 squared times 1 over 6 plus 5 squared times 1 over 6 plus 6 squared times 1 over 6 minus 3.5 squared. That is equal to 1.71, or simply the summation of our variance, or the omega squared. Then it will be the square root of 2.92, which is equal to 1.71. That concludes our lesson for today. Hope you guys learned something, and good luck on your finals.